This is section 11.2, and in your textbook, that would be on page 756. I would recommend that you look at that page and copy down the definitions that are highlighted. I'm going to go through the vocabulary and the notation, but I am not going to copy down the definitions in this session here. All right, so we've just started talking about circles. We talked about the different parts of a circle. So today we're going to talk about arcs of a circle and how you find their measures. So the first thing we're going to talk about is the definition for a central angle. Okay, and again, a lot of these definitions, hopefully you'll see some key words to help you think about what they are. If it is called a central angle, it is an angle that is located at the center of the circle. All right, in this figure that I have drawn here, an example would be angle BXA. All right, so again, we're going to name our angle with 3 letters like we have been doing. So if you trace it out, you can see BXA would look like that. X is the center of my circle, and that's why this is a central angle. All right, the sides of the angle, so from X to B, that's a radius. And from X to A, that is also a radius. Okay, so a central angle will be in the center, and the sides of the angle will form radii of the circle. All right. We have some arcs here. You can see we have a minor arc. So again, if you think about what minor means small. We have a major arc. Major would be large. All right. An arc is going to be a part of the circle. Okay. So my circle would be everything. If I traced it around here, every point on the circle, that would be everything. An arc is just going to be a portion of the circle. All right. So a minor arc is going to be formed by my central angle. So again, if I follow my central angle out to the edge of the circle, it stops here at A. If I follow my central angle out over here, it stops on the circle at B. So my arc, my minor arc, is going to be everything between those 2 points. So if I trace along my circle here between A and B, this would be a minor arc. All right. Notation for a minor arc, we're going to take the 2 letters. Okay, so I'm going to put AB, and you'll notice, as always, there's going to be a little marking over the top, and this time it's going to be like a little curve, our little arc. So when you see this, this means arc AB. Starts at A, you trace along, stops at B. You could also go BA the other direction. That would be the same thing. Okay, that's a minor arc. All right, a minor arc should be small. All right. The measure of the minor arc is always going to be the same as the measure of the central angle that kind of formed the arc. All right, so let's say, for example, if I told you my central angle, angle BXA, was 80 degrees, that means my arc measurement in degrees would be 80 degrees as well. All right, so the central angle will be the same as the arc measure. Okay. A major arc is going to be a larger arc, okay? A major arc is going to be more than 180, okay? So more than 180, a minor arc will be less than 180 degrees, all right? So a major arc might be something like, let me see, I'm gonna go. Okay, so again, I'm still working with my central angle with my endpoints here. We had a point at A and we have a point at B, those 2 points there. My minor arc was between those 2, that was my 80 degrees. A major arc would go all the other rest of the way around. Okay, so all of this here would be considered a major arc. Okay, since a major arc is large, again, it has to be more than 180. To determine a major arc, we're going to make sure we use 3 letters, okay? Because you notice it still has those same endpoints, the A and the B. So if I just put AB, that means minor, and I went kind of, I'm going to say the short way. If I want a major arc, we're going to use 3 letters. The letter in the middle just kind of tells you which way to go around the circle, all right? So let's say I start here at B, and I want to get to A, but I want to go the long way around. So if I trace, I'm going to start here at B. I would have to go past C on my way, and then I'm going to keep on going, and I'm going to stop at A. All right. So I'm going to say B, C, A, and again, I'm going to put my arc over the top. You'll notice I also went past point D. You do not need to list every point you went past. There could be a whole bunch of them there. But again, if I'm going to start at B, I'm going to go towards C, okay? And then I just keep on going until I stop at A. All right, so that is a major arc. All right. There's a couple different ways you can find the measure of a major arc, and sometimes, again, it depends on the figure. I'm going to have another example I'll show you in a minute, but if my minor arc was 80, my entire circle, in case you did not know, is always 360 degrees. So if my entire circle was 360 degrees and I used up 80 degrees right here, okay, if I take 360 and subtract 80, I know my major arc in this figure would be 280 degrees. All right, so 360 for the whole circle, we subtracted 80. Okay, that could give me my major arc measurement. All right. A semicircle, okay, a semicircle is half of a circle. So if an entire circle is 360 degrees, that means a semicircle is always 180 degrees. All right. A semicircle, similar to the major arc, you are going to use 3 letters. Again, just so that we can keep track of which direction we're going along the circle. All right. A semicircle will always, you'll always be able to find it if you can find the diameter. Okay. Because again, the diameter goes right through the middle. Okay. And a semicircle is half of the circle. All right. So in this particular figure here, we have 2 semicircles. We could say A, B, C. Okay. So again, if I follow, I'm going to start at A, I go past B, I'm going to stop at C. A, B, C. So in this figure, I would say that's like the top half. Okay. The other semicircle would be along the bottom half. Okay. And I could write that as A, D, C. A, D, C. Okay. Now, again, if I just wrote AC, then you wouldn't really know which way I'm going. That mean the top half or the bottom half. So that's why for both the major arc and the semicircle, you always have that letter in the center, in the middle there, to kind of tell you which direction you're going to follow along the circle. All right. Okay. And again, those definitions are on page 756. Okay. So now, how do you use that information to find different angle measures or different arc measures? Okay, so again, like I said, the central angle and the arc will have the same measure. Okay, a semicircle equals 180. So anytime you can find a semicircle, you know you have 180 degrees. And you also know the entire circle must add up to 360. So kind of using that information, you're going to work your way around the circle and try to find whatever they're looking for. All right. So here's an example I have. All right. And again, your figures may look different as always, depends upon, like how many, I don't know, how many radii they have, how many diameters they have, how many central angles they have. So this figure has a few more central angles than the one I was talking about for the definitions. All right. So we're just going to kind of work through this together and follow along. You can see these are all the answers we're going to try to find, these different arc measures. Again, you can see several of these should be minor arcs. That means when I write my answer, I know I should be less than 180. These two here have 3 letters each. So again, we know when we're writing our answer, that should be at least 180 or more. All right, so you can kind of keep that in mind when you're writing your answers to make sure they make sense. All right. So what I do when I'm working on these problems is obviously they're going to have to give you some number to start with. Okay, so you take a look at the figure and figure out what's going on. I'm not even going to worry about any of my questions yet until I figure out what's going on in the circle. All right, so in this particular circle, again, we have X here in the center, and I have several different central angles. Okay, So this central angle here, which would be angle BXA, this is the angle that they started me off with, and we know this is 55 degrees. All right. In this angle here, which would be angle BXC, we also see the little box here, which means this is a right angle. So I'm going to go ahead and I'm going to pencil in a 90 degrees there. What I like to do is fill in all the central angles, because once I have that, then I can go ahead and find the arc measures. All right. Now, one of the things that's very helpful, again, when you're working with these, is to try to find any semicircles, because again, we know the measure of a semicircle has to be 180. So if you have a ruler or a straight edge, sometimes that's helpful. If you can find anything that goes directly through the center, that is your diameter, and you are looking at half of a circle. Okay, and half of the circle I know must equal 180. So if I do a little subtracting here, of my 180, we already used up 90 degrees right here, and we already used up 55 degrees right there. Okay, so if I have 180, I subtract the 90 and I subtract the 55, that means this angle must have been 35 degrees. Okay, because again, these three must equal 180. All right, now if I move my ruler out of the way here again, we also in this figure happen to have some vertical angles. So again, those are things we've talked about many times before, and vertical angles are always equal. So since I have 55 degrees here, I am also going to put 55 degrees over here, because those are my vertical angles. So angle DXE would be 55 as well. All right. Then we have one angle here left. So again, I'm going to find my ruler here. I'm going to find a diameter. Again, this is a diameter, which means I am looking at half of a circle. That's my semicircle. And again, a semicircle we know is always 180. We already used up 55 degrees. So I'm going to go 180 minus 55 degrees. And that means this central angle must have been 125. So angle EXA is 125. All right. Now, to make sure I did my math right here, all my adding and subtracting, if I take all these central angles that we have here and I add them all up, and sometimes I always tell people to double check that, this needs to be 360 degrees. If all of a sudden your circle is 800, we did something wrong. Okay, so you can kind of do a quick little check here and on your calculator, 55 plus 90 plus 35 plus 55 plus 125, that must be 360. All right, that's kind of the hard part. Once I have that, now we can go ahead and we should be able to find all our arc measures. Again, our arc measures should be the same as the central angle. Okay, so let's start going through our list here. Okay, the first one is arc AB. Okay, so if you look at your figure, here is A and here is B. Okay, and my central angle with those two at the end looks like this. And if my central angle was 55, that means my arc would also be 55 degrees. And I'm going to write it here as well, because sometimes that helps. All right. The next arc we're looking for is BC. So again, we find B and C. We look at our figure. This would be the arc that goes from here to here. All right. If I look in the center, okay, that means I'm looking at my angle that's right here. And my angle was 90 degrees. So that means arc BC would be 90 degrees as well. There as well. All right. CD. Okay, so again, you find C and D. Okay, that's the arc that I'm looking for. Okay, in the center is my 35. So that means arc CD would be the same as its central angle, which is 35 degrees. All right. Next one is DE. So again, you find D, you find E. This is the arc that you are looking at. Okay, right in the center is angle DXE. Okay, so if this is 55, my arc is also 55. Okay, and again, these are all like you can tell they're supposed to be minor arcs, kind of small arcs, because we have just two letters. And again, that should make sense that all of my answers are kind of small numbers. Again, wouldn't make sense to start telling me it's 300 because we know it has to be less than 180. All right. Okay, keep on going here. We have one last minor arc on our list. We want to go from E to A. So again, following from point E over there to point A. If we look at the central angle, that would be EXA. And there we see the 125. So that means arc EA would be 125 degrees. All right. And again, another way you can kind of check to make sure everything is good, just like in the center, our angles needed to be 360 degrees. If we were to go all around the arc measurements should be 360 degrees as well. All right. Now for the major arc, you can either get the major arc by adding up all the smaller arcs that you go past, or as I said, in the definitions up on the top there, you can subtract from 360 the part that you did not go past. Okay, so sometimes one way is easier than the other. Sometimes it just depends upon how many different angles you have in the figure, or if you got your calculator sitting around. All right, so again, the letter in the middle is going to tell you what direction to go. All right, so I want to start at A. I'm going to stop at D, and I have to go past B on the way. When you're looking for an arc, again, you should never be going into the middle. You're just following along the circle. So I want to go from A towards B. I'm going to stop at D. All right, so I'm going from A, go towards B. I keep on going until I stop at D. So that's what I want. Okay. Since we have all the numbers right in the figure, if I was doing this, I would probably just kind of go and add them up as I go past. So if I went from here to here, that was 55. Then we had another 90, and then we had a 35. So these three arcs put all together to give me arc A, B, D. All right. And if you can take a look, you can see my ruler is going right through the middle. So that also hints to me that I'm looking at half of the circle. So again, hopefully if we did this right, 55 plus 90 plus 35 should equal 180 because that is a semicircle. All right. Okay, last one. We want arc BCA. So again, I'm going to start at B. I'm going to go towards C. I'm going to stop when I get to A. Again, staying on the circle. So starting here at B, I'm going towards C. All right, I keep on going, and then I'm going to stop when I get to A. All right. Again, you can see I went past a lot of other points along the way. You do not need to list them all because that would be annoying. B, go towards C, keep on going till you stop at A. All right. So for this major arc, I need all of this, in my case, which is an orange. So like I said, there's two ways that you can get that. You can go ahead and add up everything just as you go past. We have 90 plus 35 plus 55 plus 125. All of those put together would make the big arc that I have in orange. All right. Or if you wanted to, you could go 360 degrees and subtract the only part that we did not go past. This is the part was not included when I traced my big orange arc. So I could go 365 minus 55. Okay, so either one of those methods, either add them all up as you go around or 360 minus 55. Those will both give you the same answer. All right. So whichever way you like best or whichever way you think is faster. That should give us 305 degrees for that major arc. All right. So that is what you need to know to do your homework. There's a couple figures there with some circles and some central angles. They will give you some degree measurements. And similar to our example here, I would recommend you kind of figure out all those central angles that you may have. And then again, the central angle should match the arc measurement. All right. Good luck with that. Let me know if you have any questions or problems.